topic here?
I think it's semi-related, but if that's what it sounds like, then yes. Rather than looking at a single, sunset at some part of the world and getting lost over the words and what the level means and that means and this means, I want to look at all of them at one time. I want to see how they all relate to each other. I want to put a sun to the equator and see all the angles of sunsets and all that good stuff at one time. Isn't that the more powerful way to do things? But you can't go all in on that because sometimes the details matter. Sometimes you gotta not look at all the plane flights and routes at one view, and look at one in particular. Because the
Yeah, we should
devil is. Go ahead, please.
we should buy like
I mean, this guy ain't
we
saying
we
nothing,
should
Gio.
we should buy like 1,000 acres at the equator and set up a massive shadow test where we could have sticks and they would be there year round and like all kinds
Is
of
this where we have your leaf TP?
we could have those as well to measure GPs. And as the sun moves over it every year, you could get a full detection of all the shadows at the GP, subsolar point of the sun.
We got to get in the tropics. I had an idea for that earlier. I said on the stream, we're gonna want Fanta Black paint for this inside your leaf TP, probably.
Oh, you could just use
That way
water.
we make
for
sure
that.
we don't get any light. We make sure we don't get any light bouncing off weird places or something.
We just passed a
And then
special
you get
day.
the lumen detectors, and then you get the lumen detectors and stuff. Put those in the right spots, and now it's just not like, oh, did you see light or not see light? Now it's like, oh, we actually measured. There was no lumens hitting this certain spot or whatever. You know what I'm saying, Gio?
Maybe black paint. Yeah, I heard you say that earlier. I'd have to think more about that if that's needed or not. But it's a good, it's a possible
and
idea.
the lumen detector, too. Like you don't want to just go by like, oh, I see light or I don't see light. You could actually like measure it.
Yeah, that's a good idea as well. Put some of those hexagram shaped pixels that detect light. Those hexagram ones we were talking about. Maybe use those. But yeah, it would be good to have that because some of these guys are claiming you can only measure like up to like a half a degree or a degree, which ironically would be like potentially the GP, like a half a degree would be like the GP of the sun above a planar Earth. Yeah, which wouldn't match with a globe with a 93 million mile away sun. So yeah, to get more accuracy there would be awesome. And really just no one's even done that test. Like there's certain places where there's no shadow, but it seems like as far as anyone knows, even on the globe side, no one's actually tested all the shadows in and around the GP of the motion of the sun at once within a wider range of area.
Gio, how do you think you would do if someone were to challenge you to a debate? They would be the Gleason flat Earth, and you would be, not to say that this is your point, but if you had to defend just the dual pole view, would you feel confident with that? Let's say you had to do this now. Let's say right now it's happening. How do you feel that would go?
Gun to your head, Gio.
Yeah.
Well, are you talking about debating for something that I actually think is true? Because that dual pole map I've never said is true. The one
Like
that,
right now-
the one that people call that dual pole map. I've said the sky is a dual pole system, and that yes, the land must be laid out in some way underneath the sky. But the kind of map that's thrown around that concept, I have never stated that's the case. So I mean, if you're saying could I like pretend to debate for something, knowing what other people say about it, or are you saying debate from like me actually asserting it?
Let me give you an example. I don't think the Earth is
Yeah,
level.
I got a lot of crazy quotes from Gio. That's not one of them, though.
Let me give you an example. I don't think the level is planar and stationary, nor do I honestly think it could be. But if at this very moment someone were to, eh, I I could at this very moment debate someone like full gung ho on the Gleason model of FE, and I could try to defend the dual pole, and I think I could win in that. And my winning would ultimately mean, okay, so it's not about any one particular point. We would have some kind of like tally system, right? And after like 8, 10, 5, 10 points, I think after those, I think that I really think the dual pole will have more tallies than the Gleason.
Maybe, but no, I mean, it could be maybe seen that way. There's a lot of things it does resolve, but there's a whole bunch of issues with it that are considerable. And if any one of those issues is just broken, then that whole thing is just cracked. You know, so like for
So
example, one of the well, there's a bunch of them. There's just there's several things with it that are problematic. So that's, but which one's better between those two though? That's what you're saying. You feel like you would win a debate on that? Is that what you're saying?
yeah,
If you went on that
I
side,
really would.
is this the one you like? I'm posting this one, this Chamberlain.
Just any dual pole. I don't care what the map variation is. Just as long as the
That one's
Antarctica.
that was the Chamberlain trimetric. Remember that night you were using that one to you were like yelling at all the Globers like, "Do you have one better than this?"
Oh yeah, no, that's the one right there.
That was hilarious. Yeah, that one is cool. It does seem like the proportion. Although, dude, the issue with that one, imagine the sun doing a 24-hour sun in Antarctica, right? Look at those people up in California where I'm at. They're shooting off to the upper left. You know what I mean? Like, so the sun's like will set south of east for me in the wintertime in California. But look where California is on that. You know what I'm saying?
Yeah.
And with a looping sun around the south, like 23.4 degree around the south, it's tough to think how that would be setting south of east, you know? Looks like the sun would set like you know, basically west of south. So that's one issue with that one. But yeah, that one is you were saying that one's good for distances. Also Australia is somewhat a little bit more normally shaped on that one too.
You just got wrecked before the debate even started.
That's what I'm saying, dude. The dual pole has some like there's like it makes me think of like a vase that has like big cracks in it that if any one of those cracks are fully cracked, the whole thing is just that whole layout would be problematic, you know what I mean?
Let's say an arbitrary, fictitious, hypothetical hill to die on. If everyone had to participate, whether they're flat or globe or undecided or any other model, it's literally. And this is not to say that flat Earth is bounded by these limitations, but just literally straight up flat or dual pole. That would be an interesting one if the whole community can battle it out over those two.
Well, the thing is, the sky does have two poles, and that it would be good to confirm that more fully. Like, for example, like if you're in equatorial Africa and you see the northern rotation, and you look at the center of it, which Polaris would be just about setting if you're at the equator. But even if you went a little north of it, if you just started walking towards that North Pole, would you actually end up underneath it? And then the one in the south, Sigma Octantis, that whole rotation, same thing. If you looked south, you went a couple degrees south of the equator, and now you see Sigma Octantis. And even though it's a very dim star there, you can use the pointer stars, and you can use the Southern Crux and the Southern Pointer Stars to actually find the middle. So if you just did that, and then you followed that, you can also just see the center of rotation. But if you traveled all the way there, are you going to end up underneath that? And if so, I don't see any other way that it's not a two-pole system. Because then when you have all the GPs, if you're getting to the GP of the two pole stars in that case, and then you could get to the GP of any other star, then the way that sky is laid out would have to somehow be, above the planar Earth. And however the continents are laid out, that would be a question. Now, if you bring something else like like a lenticular sky or a holographic sky or something like that, that's actually like evolving as you move, well, then that brings a whole nother complexity. But the two poles and being able to walk underneath, if you could do that, to either pole star, would be pretty much indicating that. I mean, if you're getting to two places on the land that are two central poles, then obviously the continents would have to be laid out on a planar grid, between those two poles. If you can walk from the equator to either one, I don't see any other way that you would not have to have the continents laid out between those two pole stars.
That last video I uploaded, or it's like an animation. It purely shows the distance discrepancies between these two models, and so actually what this is each pixel from one corner to the end to the represents data. So if one pixel in one, dual pole looks bigger than the Gleason variant, then that means that either model has an inherent distance discrepancy between the two. Does that make sense? So basically what this short video is it's just a short transformation between the Gleason and the dual pole. And these green and yellow and purple light lines and dots represent literal mathematical transformations. It would have to be this way if the world were to be set up or laid out in any way like the two variants. And I could do this also for other variants, but these two ones are the leading ones. And if one were to play this, they'll notice that there's really two regions of major distance discrepancies between these two models, between these two flat Earth models. Just these two setups. Not to say it has to be this way or anything. First one's Antarctica, and then the second one is around the Hawaii region. They're inverse of each other in terms of what they geometrically and necessitatively would claim that these regions of the world would be skewed. And one of them, Antarctica's big, and the other one's Antarctica small. And the other one is that region around Hawaii, somewhere around there, like in the waters, is one size, and the other one just blows it up and warps it. Not to say it's right or wrong. The dual pole model, as far as this distances goes of the known continents. Okay, so the globe, ball, and then there's continents, there's land masses, there's ice masses placed in places around this ball. In my opinion, the dual pole flat Earth is closer to the glober's distances. Meaning the dual pole flat Earths, like, for example, Antarctica, which is small, is closer to the distances that globers measure. Just south and north. So just looking at this from a very large scale, if one were to disprove dual pole and choose the Gleason and actually beat the dual pole over Gleason, you would have to disprove the glober's distances. It's like that. In order for the dual pole to be wrong, as in terms of just the continents, because there's a lot, there's oceans and stuff. We're not talking about the oceans, just the continents.
Oh yeah, because on the Gleasons or AE map, it spreads the south out. So you know how we see the two rotations of stars, and then like there's elevation angles coming out from Sigma Octantis, and then there's elevation angles coming out from Polaris, and those are of equal value, like they're symmetrical. That's why when you do elevation angles in the south to Sigma Octantis, you're going to get the latitude in the south, and when you do it in the north, you're going to get the latitude in the north. And there's a consistency, and we can see the two rotational star fields look quite similar. Like they're different stars, but they look very, very similar in terms of like the concentric circles going out. So if you have land underneath all of those, and if they're symmetrical, then the distances between the southern continents would be symmetrical to the distances that coalesce in the north. And the AE map is the only one, the Gleasons type AE map is the only one that like spreads those out to the outside, and therefore expanding through a lot more land. And the Tropic of Capricorn has to be much wider. And then the distances would have to be great because now they're being spread all the way around the outside. So yeah, I've always said those distances would really have to be a lot further for it to, for that Gleasons map to even be viable. And seems to me with like flight speeds and all of that the continents are coalescing to a southern pole the way that a globe would. It doesn't mean it is a globe, but because I mean some of these two pole layouts, it's basically just it's a stereographic projection of a sphere on a flat plane. And stereographic because you have the two poles, and then it's a flat representation of that. So it's similar to a globe, except the globe puts the Pacific Ocean around the backside of a ball. Half of the globe Earth is the Pacific Ocean, whereas this makes it flat and has the Pacific Ocean as like a rim around the outside, like the Pacific Rim kind of idea. So yeah, so it's going to maintain those southern continents being closer on the what's referred to as this dual pole, or technically on a globe, which is also like a dual pole type system.
You see that primitive image I just posted?
Did you cut out or?
You see that image I posted?
Yeah, 1,000 miles. It says.
So it's just a simple concept. It's a line at the bottom to represent the ground, just 1,000 arbitrary miles. We're not doing math or numbers here, just visual. And then above this 1,000 miles, put in no particular order. It's all arbitrary. I just put various symbols. So this is like a symbolic representation to represent an idea. Let's say on a globe, okay? They have this 1,000 miles, and then in that 1,000 miles, there's water, there's a boat, there's a plane, there's clouds traveling. So everything's going to be moving. Boats, planes, the sun, you could see go overhead. There's stars. These stars, they're not labeled. The labeling of it is important, but for now, we don't care. There's stars. There's those rectangle things. Those are like cities, skyscrapers. There's a car. There's a person. Car traveled. Travel on foot. Mountains. All of this is contained within a 1,000 miles, and the line beneath it is just to like represent like this 1,000 miles is stretched out. It's because distances are not the same in these models. They're not the same. First of all, in any globe versus any planar or stationary flat, it doesn't. The rotation actually doesn't even matter. Just globe and flat, the distances will never match. There has to be a breaking point somewhere. We can talk more about this earlier if anyone like really disagrees or it's like blowing their mind. But like we've all heard, oh, they're kinematically equivalent. There is no equivalence. Nothing is equivalent. Distances, orbitals, observations. There is no equivalence. So if that has like piqued your interest, write this down because we can get to it. But the point is that a globe and a flat, there is no equivalence when it comes to the whole world. It tends to be that in these Gleason, these dual pole, this rectangle, there's various setups we've seen, and in these different setups, some portions of the world are more closer to the globe. Not to say the globe is correct, but closer to each other than the other ones. So like Gleason may be like more closer in the north compared. But somewhere on a flat versus globe model, any model, as creative as you want it to be, there is a breaking point where the distances don't match. And they don't match. The breaking point is not, oh, it's just like 10% off, like mathematical error, like with the winds or some Coriolis or some magnetic declination or some ether spin, or they're off by a lot, like 7, 6, 5 times.
Yeah, no, but what's off
what's
off the globe model you're given or actual reality?
Good question. But the point is, and let me end it now. When one line of distance stretches, everything stretches. The clouds are having to travel faster. The sun is traveling faster. The stars are rotating faster. People on their boats are rotating faster. People on their feet are moving faster. Planes are moving. Anything from a point A to a point B, when the base template, when the base line, when the base 1,000 miles gets warped, like Antarctica, for example, right? One of them is small and one of them is big. All other distance phenomena also necessitatively has to get warped. The stars are no longer 69 degrees per degree, or 69 miles per mile, whatever it is. Same with the sun, with clouds, jet streams. Oh, in the North Pole, there's 400-mile jet streams. And the Gleason model, they're not 400 miles. They're not. They're. It's like 1,000, 2,000, 3,000. Same thing with planes. Same thing with boats. Same thing with oceans. Same thing with a man walking on his feet, taking footsteps, claiming he got from point A to point B. So what does this mean? This is just info for everyone. When we hear, oh, well, I heard of this evidence. There was this sailboat race, and this sailboat race, the winds were pushing it, and that explains it. Whatever. That's not enough for you. The clouds have to match. The stars have to match. The sun has to match. The data has to align and correlate. That's all. Thank you very much. So when a flat earther comes and claims, oh, my flat earth model is better than your flat earth model, there's a lot to go in. There's a lot to go into that. We don't even need to talk about the globe anymore. Let's just say Gleason versus dual pole. Oh, well, not to say one's right or over the other, but one of them has a big Antarctica, one of them has a small Antarctica, and they're really large and different from each other in size. They're not like a little 10%, 20%, the wind's pushing you type thing. Once you grasp this magnitude in your mind, you could start playing with the numbers and visual and data intelligently. Anyways, that's all. I think someone wants to say something.
I think we've already done that. We're in a flat Earth debate, and I think he's talking actual geo. The only way you can figure it out, physical measurements, like the actual physical attribute of the dirt and water. Yeah.
Let's take the globe out of it. Let's say tomorrow a flat earther comes and makes they come here and makes a video or a fucking really arrogant statement, really loudly, confidently, more confident than you or anyone else in here, claims one model is superior to all the other flat earth models. How do we go about, what do we do with that?
I never put it in. I never put it into anything. You don't need it. You don't need a globe model for anything.
Like if tomorrow someone comes and says, "Oh, all of you dual pole earthers, you're a shill. The government's paying you to put out this fake fucking disinfo, and my model is this one here." Like, how does a truth seeker deal with that? Like, okay, so first of all, this person didn't make any globe claims, okay? So it's not, I can't just automatically side with his, let's say he thinks the Earth's, stationary and planar, and I know that that's what the world is. He didn't make it easy for me to just choose one of the options. How do we know? Like, what do we know? Well, it's a difficult process, but the way we could break it down into chunk-sized pieces is what I described earlier. You could start really making evident to your mind the real differences between them.
That's what a hypothesis is supposed to be. I have a flat distance that I got to work with, or a rounded distance. One of these things are not like the other. So they're not the same. They don't act the same. They don't look the same. They don't feel the same. So you just have to have the two references in reality, geometrically, like physically. Physical Earth curve next to a physical horizontal. I mean, it's pretty simple. And once you test those things, make them as long as you want. Once you test them, you're good to go. You'll see what they do or don't do. You don't have to keep making stuff up. Making stuff up, whether our reality is this model or that model is stupid. Reality's not going to change. What the sky is doing, they ain't going to change.
What do you think about this, D-Mock? Look, so we're okay. So we're keeping everything else out. We're just talking about planar stationary Earth, right? Let's say let's pose this question to you, and I'm not going to talk too long. Let's just say tomorrow D-Mock
do
comes
that,
out.
though.
Let's just say tomorrow D-Mock experiences a dilemma, right? He's got one.
Yo,
of
he's
his,
not interested, dog.
Oh, he's not interested. All right.
He don't want to join your fucking
I-
concave cult, dude.
All right. All right. All right.
Fuck out of
whatever.
here.
No, I'm saying you can't have
Hey,
only one without.
Agent Smith has you, but it's okay. Go ahead.
No, you have to have a comparison. The whole reason for a debate's not to say we only have this thing to talk about. You have to say, is it this or is it that? What does our reality match? So no matter what we look around and see in reality, it's only matching one thing, man.
So
And that
like,
is what? Flat or round. So
okay,
it's
so
flat reality or round. That's it.
okay, so no round. Let's say someone joins in right now and says, "You know what? Fuck all of you guys. You guys sit here and you listen to this chilled fake disinfo dual pole flat Earth model. We know what the Earth's map is. It's like the Gleason map. It's like the map we've seen in all of our flat Earth videos. You all saw it 10 years ago in 2015. You've got no excuse to fall for this disinfo models. And this person claims, let's say hypothetically, or this whatever. Oh, the dual pole map is wrong, and it's actually the Gleason map. Like, how is a flat earther supposed to confront that?
Well, what if it's just not either? Because I don't. Dude, I haven't mapped the Earth. I mean, we're given information, third hand and so on. And I know that obviously there's plane flights, there's traveling. I mean, there's claims that you can just go across the Pacific Ocean, like even in like your own little boat if you want. And some people have claimed to cross the Pacific and so on. Meaning, like, if you're out there, you're going to have some level of awareness of distance and speed to even get places. So, yeah, but it could just not be either of those, the Gleasons or
Let's say
that dual pole type
hypothetically,
layout.
you have a person coming out with a alternative layout, and it's different than the Gleason and the dual pole, and they're claiming anyone that subscribes to all these other models or even looks into them or like takes them into consideration, that they're either paid or they're deceived. Like, how does a truth seeker at this level of the game, taking out the globe, how do we determine what's real and what's not?
Well, that's discerning truth. Yeah, being able to discern the truth. Whether somebody's paid or not, I mean, first of all, NASA, all of the mainstream people are already paid way more than any little like fear of some agent online. I mean, NASA's already got billions of paid people that are pushing all that. So, well, I said billions maybe. Well, it probably is billions, and all the people that follow them as well. But all those people are not paid, although they are paying for it in their taxes. Really, they're just paying to be deceived. But in terms of like what the Earth is, I think people are just trying to figure it out. It doesn't seem. I mean, there's people that are either pushing a model, meaning they're really asserting it, telling everyone else it's the truth, and putting their name behind it or whatever. And then, so there may be some of those that are doing that. But there's a lot of other people who maybe would just admit honestly they haven't mapped the whole Earth, and so they're not decided on what the map is. Even if someone gave you the correct map right now, like, wouldn't you have to go check it anyways to even check if it actually fits to reality?
Let me
compare it to the globe. If the globe's false in the first place, then you're not going to get too far comparing things to a false globe for being what the actual truth is. So it's just a much bigger quest than just being able to maybe crunch it out from what we have access to right now.
Let me give you an example. Let's say someone challenged you to a debate, and they were I guess like a Gleason flat earther or whatever. And honestly, I want to take you out of this because, like, I don't want it to have what would Geo do. Just like, let's just say one person who's been researching the dual pole flat Earth model or setup or orient, however way you want to call. How would they? What's the? How would they? How would we move forward? Like we.
Well, okay, I'll just say briefly, I have not proven the Gleasons or AE map false. I don't think anyone has. So, I mean, has anyone really proven that layout false? But has anyone proven it true? I would say neither.
So
to either.
let's trade a hypothetical because we can't move forward, with the understanding that it could be anything, right? Let's just say if it had to be. So this is all just fictional. So everyone can put down their guards. No one's representing themselves or their model or anything, right? If it had to be between dual pole and Gleason, like in this hypothetical world, it's one of these two. How does one figure out which one it is in relation to our community? But it's all good. If no one's interested, let's just move forward to whatever's next.
Well, Lion, are you at your mic? I think I've asked you this before, or anyone else who wants to respond, but like in terms of it not being some kind of dual pole system, if you could go from the equator and walk literally to one of the other two poles, would that not indicate it has to be some kind of a two-pole planar system? If you can walk from the equator to one pole, then go back to the equator and walk to the other one, and you're going to actual like the center of those two star rotations? I'm not saying that dual pole map exactly, like not the one that's being kind of talked about and being called that. I'm just saying a dual pole system. Like the land would have to be laid out between those two poles. Then if you get the 24-hour sun at each one as well, even though the sun doesn't even really matter, the stars are already doing those rotations. The sun, people make such a huge thing about how something somehow changed with the sun observation. Not really. I mean, if it were to go around one pole and not the other one, that would be different. But it's not necessarily like it would be different if it only went around one pole rather than going around two. That is the case. But what I'm saying is that the position that the sun goes in the sky, there's stars in the sky as a background that the sun is moving within. And those stars are already making like what we call the Tropic of Capricorn. The stars are already making that circular rotation that we can see when you look at the southern star rotation. You can like spot the Tropic of Capricorn. You could point to it and be like, yep, there it is. And then, if it's that time of year or a couple months later, the sun is going to be right in that same track where the stars are. So, I mean, the stars are already doing that rotation in the south around Sigma Octantis, always have. And so whether the sun does it, well, I mean, the sun goes to that part of the sky and those stars are going around Sigma Octantis. So it already is kind of indicating that. But I'm just saying the stars themselves are already, there. And so, yeah, I asked Lion. I don't know, Lion, if you're at your mic. If not, if anyone else wants to respond. But I'm just saying, like, can we fairly easily validate that there's two massive star rotations that we can go to across the Earth, which would mean that there would have to be some kind of two-pole system? That's the question. And I'm not asserting it like it's absolute. I'm just saying, does anyone have any way that would not be the case if you can walk to the two poles? It's like if you're in like a football field, one guy goes to one side, he's like, "Yo, I'm here," and the other guy goes to the other, and you're in two end zones. You just like there's two end zones, like you can validate it. You're going from one to the other. Like if you went to the middle of the football field, one guy walked to the one end zone, the other guy walked to the other end zone. You could both like scream at each other, like, "Yo, I'm at an end zone." Like you would be able to confirm there's two end zones. But I mean, what the whole map is, Gatebreaker? Yeah, dude, that's a huge question, and it's probably something like that Mercator, which is kind of like the dual pole, but it seems like it would have to. With two poles, you'd have to have like four quadrants, which is why we call it the East and the West. You have like the four sections. You have like the North America, Canada part. You have the South America part. You have the like Russia, Europe, all that, and then you've got the Australia, and then the middle in Africa.
That's good. I know in QOP server there's been a almost cultural imperative to focus on models, but like, what does a model mean? Basically, a construct, whether it be in, you know, in words or in MS Paint or a 3D model or done with mathematical formulas, that takes into consideration all the supposed rules that is made for every other thing. So for example, you know, if in one observation one claims, oh, you know, light's bending up in my model, you know, and then they ask, why is light bending up? And then they may claim, oh, it's bending up for so and so reasons. When they're modeling out their sun, or when the sun is taken into consideration, those so and so reasons need to be accounted for as well. It's not just, oh, just, you know. Same with distances and observations. For example, if an observer in the North Pole is looking at stars and they see the northern stars all around them, above their head and then dip down to their horizon, we call those the northern stars. They were, if that's what they were to see, and then that person has an understanding, oh, well, the reason why I don't see the other stars is because they're beyond my range of vision. Due to perspective, they're just over there, and if I were to go closer to there, then those stars that I don't see would be above my head, just like the stars that I see right now are above my head. If I were to go over there, those stars would be above my head, and then the stars that are currently above my head, I won't see them because they're beyond my range of vision. And then these things are tested for. Tested for what does tested for mean? All these there's different levels to do this stuff, okay? At the highest level is pure math, pure software, pure math, to the likes that no one in here and anyone you've talked about can do. No one can do. No one does it. These are specialized people that clock in and do this shit for a living, and they don't bother debating or talking to people like us. That's the way it works, okay? That's the highest level. No one in here has it or has done it or probably could do it in the foreseeable future, okay? So we're all working with lesser degrees of doing things. In one
I mean, if
way,
that's how you feel about yourself, but speak for yourself, don't project on it.
This is a reality. It's not a projection. This is the incorporation of humbleness, of biting your own ego, of seeing things the way they are. But it's not about that. Anyway, look, I'm not trying to preach, man. I really I want to add what I can if it's on point, but it feels like I'm preaching right now.
Yeah, but he's never talking actual. He's just talking like nonsensical ideas. You got to stick to one or the other. Like stick to something, hold to it, try to figure that out.
The idea of like an apparent sky over a Gleasons or AE map is an interesting one, but the thing about like what I was saying about going to the two poles seems like would falsify that, because if you were in like South America and you see that southern rotation, which we all know we do. I've been to South America. Others can go there. It's clearly there. If you go to Africa, people in South Africa, we know it's there, the southern rotation. Australia, we know it's there. People in Australia all the time. So we know from all those points, you're seeing that southern rotation. So if you were on a Gleasons, if it was spread out like that on all different, different edges of the circle, then those people who were all seeing that rotation, if they all walked to the south, they would not end up in the same place. They would end up on, three or four different, if you also did it like from Hawaii, for example, or something, or south of Hawaii. But if they would all go to like, let's say three, if you take those three continents, to three completely opposite sides of this huge realm, rather than going to the same exact point. And I mean, I've never been to that 90-degree point, the Amundsen Scott base station, but it does seem like that's a place. People go there quite frequently. There's a good amount of footage from there, and then we can see the star rotation as well. And then you can also go like further south to those further southern regions and so on. So Yeah, I mean, but it would be like if we could confirm that. That's what I'm saying. Anyone who still thinks it could be a Gleason or an AE map, would they agree that if everybody went from those continents and you all ended up in the same place, that would be falsified? Like if you physically all ended up in the exact same place? So yeah, I mean, that's a test that we need.
The question is that has it been done?
Right. No. Well, they claim you can fly from South Africa to like that company called White Desert, where they have those like they're more like luxury style Antarctica trips. They're not at like 80 degrees though, or 79. Those are at like 72, 74 degrees. So they actually don't really get the full 24-hour sun. They only get part of it. But yeah, they claim that you fly from Africa because that company is based in Africa, and you fly to that White Desert. That's a part of Antarctica. And then there's the South American route where it seems like you can go through Punta Arenas to Union Glacier. And then there's the Australian route, which is to McMurdo.
Not to Union Glacier.
But to then prove that all those points would then fly to one central pole would be what would be needed. But I mean, they do claim they fly from those continents to Antarctica. And then all those flights, all those places do claim that they have short flights that go to the South Pole. That's another thing. Like the Union Glacier has like they use Union Glacier as like a pit stop to go to the 90 because they're at 80. And then apparently what's that company, ALE? They also have a camp. I think it's called like 3 Glaciers, something like that, like at the 90 degrees south, which you can, those trips are like 90,000, like 100,000. But apparently they claim they have those trips too. And then the White Desert, they have like trips that go from their White Desert camps to the 90 South. And they claim that's like a short, like you can like pay extra basically, and it's like a short flight. And then McMurdo, yeah, they claim that there's like different military outputs and so on that fly through McMurdo to the 90 South. But I'm just saying what's claimed. I haven't obviously taken those flights or confirmed them any further than just what they're advertised as, or that they do exist. I mean, when those guys were in Union Glacier, there was a woman that was saying that she was flying to the 90 degrees south. In fact, she's in that footage. I think it's on like Jaren's webcam where they're all like smoking cigarettes. I think she's, because Witsit had talked about her, and I'm pretty sure that's her when they're smoking. And he said that she was like just flying through. So I mean, you'd have to take their trip as valid, and then also accept that that she was there or whatever to consider that as evidence. But at least from what Witsit was saying, that he talked to her and she said that she was
Won't
flying.
be doing that.
They also have a ski the last degree. They have a ski the last degree trip where you go to 89 south and then you ski the last 69 miles to the 90.
Yeah, but the problem is still having all made up at one same location, coming from different directions.
Yeah, I wouldn't say that I've seen it confirmed like fully verified, but it does seem like it's there's a lot of documentation that it occurs, but I haven't really met anyone who's done that. Who's gone from all those points. There's also footage at the 90 South point of the, I don't know if I've ever, well, there is the Anthony Powell has those like 24-hour sun and 24-hour moon videos there.
Gio, you know how compared to the globe. Okay, so anything I say, you don't have to answer. Okay, you know how compared to the globe, the Gleason map, its breaking point, and I know you don't know what that means, but you'll know in a second. Compared to the globe and the Gleason map, the Gleason map's breaking point compared to the globe, or vice versa, is the South Pole. Does that make sense? Meaning, if you take a globe and you take the South Pole of that ball, and you poke a hole in it, okay, and you flatten it out, and you just have these rubber ball pieces. You have 2 layers right now when you flatten it out. So we got to pick a place in this flattened out ball that gives us 2 layers of material to split it apart and make it one plane. And what the Gleason map
Inside the
is,
outside of a magnet.
what the Gleason map is you have a rubber globe ball with the North Pole pointing upwards. You poke a hole in it in Antarctica, in the middle of it, just in the middle, the other side of the bottom of the ball where it makes contact with the fucking ground. This thing deflates, and you smush it on the flat, and you have two layers connected at the seams. The middle of the top layer is North Pole. The bottom of the bottom layer, which is touching the ground, is South Pole. Right now, we've got a double-decker planar flattened out ball. We need to make this one plane, one layer. So where do we cut in this ball to make it planar? What the Gleason map is, is you take a ball, you flatten it out, you have 2 layers, you poke a hole, you get the middle of Antarctica, the middle of it, and you start cutting triangles from that center point, okay? And then you splice that motherfucker up and you flatten it out where the edges of those triangles, where the vertices of the triangles that were connected to the center point are now at the...
You can be on. Is he done?
I think he broke up.
Oh, okay.
I think he cut out.
Okay, you can be on one side or the other side of a magnet. Like I got a circle magnet, the one that's got the outside edge and then like the inside hole in the middle. That can be like the landmass can act like that. And then depending on where you are orientated to that's just going to be it. But still, that has nothing to do. Like there's a 23.4 degree tilt that means nothing compared to nothing for no one. When we have
it's
a
just the
flat
distance
surface
between
of-
the equator and the tropics, which is the band at which the sun travels. But yeah, they call that a tilt, which does. Yeah,
right.
you're right.
And how could you reference that for vertical versus plumb? You know what I mean? Like what's verse that's not I don't know. I understand what you're saying, but yeah, for them to be able to prove that thing is going to be, yeah, I don't see how.
Dude,
they
have you
can
seen
prove
how like a toroid breaks up, a toroidal field? How you have like the upper half and the bottom half. So you have like the
Yeah.
northern hemisphere, southern hemisphere, if you will. But then if you put it sideways and you put it flat down onto a paper kind of thing, or down onto flat onto a surface, you would still have the 2 hemispheres. But then you also have like the quadrupole, because you have like the northeast, the northwest, the southeast, and the southwest. So you would then end up with the quadrupole. So like the
Yeah.
toroidal field, it separates from the middle, like what you would call the equator. And then it separates vertically, like what they would call like the prime meridian. And then it does seem like the globe is like stitched together, because like the whole backside of it, how half of it's like the Pacific Ocean. Then you have that international date line, which I know they claim is like arbitrary, that it's all, jagged and angled. But if there's any place that could be stitched together, the Pacific Ocean does seem to be potential for that. But if you have like a toroidal field that's out like that, you get the single pole through the middle, but then you get the dual pole, 2 hemispheres, then you get the quadrupole. Basically, it also kind of keeps breaking down even from there. And if you kept breaking it down entirely, you would end up with like a sacred geometry grid. And then the places like Egypt, Machu Picchu, these different like energy spots then end up being like nodal points of all of the different like field lines of a toroidal field that start to intersect and make that like, you get into like sacred geometrical grid patterns that come from that field, which is one electric field is too. Yeah, that's why I got sparked on that, because you mentioned the electric field where you would have these different, just being at different regions within it.
Sorry. Like a circular ring, like a field in a ring in a circle.
Well, it's like, you have like the 2 lobes of your brain, like right brain, left brain, but then you have like, well, yeah, it's just how a toroid keeps breaking down.
Yeah, but I'm talking just take a circle magnet, sit it right down there on the table, It's the same. You can be inside of that or outside of it. You can be on anywhere around it, and you're going to get that circle effect along that line, and it's going to draw something towards it or to the edge of it the same way that we see. If we're little bitty and the magnet is huge, right? The plane we live on acts like a magnet, right? Like almost like a circle magnet and not like a square one. If it acted like a square one, it could be the four thing. If it acted like a circle path of magnetism, right? Then it could just be you're inside of it or outside of it. It doesn't necessarily have to be the bar magnet with the brain and the. It can be set up a little different. Is all I'm saying. I understand what you're saying. Yeah.
The inside outside dilemma is reserved only for concave Earth and globe Earth.
No,
That's a
what are
whole
you talking? I'm
nother.
talking about
That's a whole
magnetism. I'm not
nother.
talking about in a ball or out of a ball, dude. Stop. I'm talking about on the ground. You put a superconductor. You can either get inside the superconductor ring or outside of it. Get in where you fit in or step outside.
I see. I was just seeing it from a large scale, like like world size magnet, and you were to place your map of
Yeah.
continent. All right, yeah. So if that's it. Let me
And we're
stop
all
there.
either inside or on the outside edge of that mug trying to figure out, hey, what are we doing because this field's throwing us off or making us direct.
Well, you'd know
Yes.
by comparing the field geometry with the fucking map. That's you'd know, and flat and globe can't be the same. So that's how you'd know. That's how you know if you're inside or outside is by, well, first of all, okay. So the inside and outside a dilemma is even actually beyond globe and flat, because that dilemma is not globe flat cross shape. It's actually like flat. That the real root of that dilemma, the difficulty of settling that rabbit hole is not globe flat inside or outside. It's flat inside or outside, because the geometries are the same and there's other things like that. So just trying to add more spice to the regular convo.
Is there any way like a lenticular sky could like change as you move to the point to where that southern point would be moving as you're moving, and therefore it would end you in the same place, but you still wouldn't be in one place on a plane? I'm leaving the globe out of it. I already know it's not a globe, so I'm not really that like I'm even considering that. So, but in terms of is there any way lenticular sky could actually like move as you're moving, that it would take you all to one point and all three of those people, if you started walking towards it? Well, the thing is though, you have Polaris though, and you have the elevation angles. I'm just thinking out loud. Sorry, I'm still thinking about that from before. If the sky was like always changing its like refractive qualities as you move. Sorry if that was a non sequitur from what you guys were talking about.
No, it wasn't. You're thinking. We need to hear new ideas.
Well, it would still be leading you towards one point if you did that, but it would like if it's a reflection, could it like almost like a funhouse mirror, could it keep changing as you're moving? I mean, that was an idea that we've talked about. I think Babooner, remember, he was talking about that idea. It's like the GP is not actually set to a point, but it like moves as you move, like other GPs move as you move. Gatebreaker, can I just ask you a random question just out of the blue? It's just kind of connected to it is connected to this, but it's not as much on the technical side. But do you really think there would be this much energy for these discussions? You know, this much like just over the years, like sustained interest, focus, you know, et cetera, in terms of the discussion about the shape of the earth and obviously all the spiritual and religious components of what humans used to think the earth is, the whole globe model today. And I'm not saying it's like a mainstream discussion as much because obviously the mainstream kind of suppresses the idea that it's not a globe. But it's just a general question. Do you really think there'd be this much energy and people spending like basically, you know, a lot of people like on a daily basis, even if they think it's a globe, but they're still spending their time and just all of the energy of the debates and the characters and everything involved. Do you really think it would be this significant if it really just was a globe? Or are you able to consider that? I know it's kind of a whole different level of analysis, but that there is something going on, the fact that there's this much focus on it and this much human energy is being put towards it. Like, do you consider that that alone indicates that, like, as much as some people try to troll and say this is going to go away, it's really not in terms of like what the truth is with this, and that the globe is problematic. Like I'm saying, can you tell from the fervor of energy of people, the discussions, that the globe is false? That's kind of the question. Because of the amount of focus and people dedicating their entire like, you know, life's interest to it, even like retired PhDs and stuff.
There's many ways to go about that. I mean, it just depends. I don't know. I don't know. It is what it is.
And people
I know
are thirsty.
It's a totally different angle of analysis. We were talking about like distances and fields and stars and all these other things. So we can stay on that. It was just something that came up in my mind earlier. I know it's like a sociological question though, or like psychology or sociology. I guess it would be like the analogy. We always make the joke of like, you know, if people said pigs can fly, because some people that are like, oh, it's so obviously a globe, quote unquote, it's not flat, it's so ridiculous. That would almost be akin to like, they think it's like someone saying, oh, pigs can fly. But if somebody started talking about can pigs fly, do you really think they would be able to get like a whole decade or more of where there's like people that have been in it and all the characters and energies and focus and interest on just something like pigs can fly?
Yeah, but people believe in Sasquatch, right? That even though we know that that's like going to be impossible for a whole bunch of reasons, right? But people still believe in that.
Yeah, but do they have entire
I think you can tell Gio by the reactions that people have. Yeah,
I mean, people. Yeah. There's whole communities about alien abductions. There's whole communities about like stuff like that, right? That I think is a lot more nebulous. And the thing is, this community is tiny. Like everybody knows everyone. I mean, it's like as small as like it's literally like almost like a private school or even smaller, right? Like there's just like a handful of people. Everybody knows everybody.
Dude, you haven't checked TikTok. There's a shit ton of people.
I'm talking about the people that are like regularly involved in discussion, not like.
No, you're just talking about Sounds like you're just talking about Discord, which is not.
No, I mean, just like amongst like
you might just be trying to stabilize your own confidence in the subject, maybe.
Like I'm just talking about
it's
like
way
people
bigger
that
than
are
that,
in discussion, right? Like
it doesn't sound like a coping mechanism, so I guess you can't tell like how people react to this topic, and so good on you.
Well, then you have all of the freedom fighting doctors. They're all flat earthers except one. You have like those outskirts. There's who's the Alex Zach? He's a flat earther. A bunch of the guests he has on, same thing. Like there's a bunch of other people that just aren't in regular discussions, and it's not their topic that they do content on, but they are flat earthers, and then people they have on, they're willing to talk about it. So it's bigger than just Discord, Twitter, X, whatever you want to call it.
this was specifically about the people that are directly involved in debate and discussion about it, not like someone that has a passing interest in it, right? And if we're talking about like all the guests that have made all the rounds between, all the flat Earth related channels, right? Like it is a small group of people.
No, I mean just maybe there's people. Most of the people know each other, but if you go to freaking TikTok, it's so many people that are there discussing it freaking daily.
Yeah, I thought Gio was talking about the fact that the conversation continues for long periods of time. If it was so stupid, or if there was no validity to it, then why would it continue? That's where I thought it was going.
People like talking about it. That's why.
Yeah, I mean, people argue about chupacabra. People argue about whatever. What was that creature that was on the East Coast with the red eyes? Right, like
Those really aren't the same though. Like there's not a whole slew of like anti Sasquatchers who go after into Sasquatch forums and constantly do that. There might be people on the internet that post, "Oh, I think it's false," or "Here's how it's debunked," or whatever. I'm not saying nobody's talking, having some posts about it, but the shape of the Earth discussion is completely different than all of those you just mentioned, I would say. And there's a consistency of constant energy involved in discussing this, and people who even claim that they're against it have dedicated like their entire lives to it. It seems like, even like I said, PhDs and others. And I guess what I was more asking, because like this question of like, we're talking about distances and the stars and all these questions, and if the end of this, like, if people think it's a globe and they think that the end of all these discussions is just going to be, oh, everyone like they finally do prove the globe or whatever to everyone's satisfaction. If someone thinks that's going to be the outcome, that doesn't fit with the amount of energy that has been involved in this and the amount of energy that's been against defending it, like defending the globe model. Like there's that meme where it's like, it says like, if you're lost in the woods and you just start talking about flat earth and someone will show up to come debate you. Like that is a thing, whereas like,
Yeah, and like YouTube openly saying that they have to shadow ban it in court.
I don't know. Look at like for example, Christians, right? For them, the proof of Jesus being the true Lord and the Trinity and all that, to them, that's just like as obvious as anything else, right? As the fact that the sky is blue. But yet there are still people that are arguing that, right?
The
Well, you
number of
don't have the
people who are
government
anti-Christian,
telling people to censor that.
the number of people who are anti-Christian far outstrip the number of people who are anti-flat earthers. If you look at the anti-flat earthers that are in here, almost all of them, not all of them, they're all anti-Christians. If you really get down to it. I mean, actually, I chat with him a lot, but he's anti-Christian. I don't mind because whatever, man. But yeah, he's actively anti-Christian, anti-Bible.
And algorithms will pump them for being anti-Christian, but no algorithm is pumping anyone making flat earth content. Doing the exact opposite.
MC Toon is one of the biggest anti-flat earthers. He's not anti-Christian. He considers himself a devout Christian, right?
Yeah.
I don't know if someone broke up. I mean, we can go back to the other combo if we want. I was just bringing up more of a point of like coming from a different angle. There's either something that humanity is working out with this question and it's had this much fervor and characters that have been in it for years and years. And what does that mean? What does that represent? Because if you're thinking that it's just all false and the Earth is a globe, why would there be this much energy and focus and people dedicating so much energy either to defending it or asserting it or debating it or working out all of these? And it's obviously a complex question. It's not just some like close and shut case. And even a lot of the globe guys will admit that, if not most, will admit it's not just an easy close and shut case. Like that they're even like people like PhD Tony have even said that like there's a, well, anyways, I don't want to speak for him if he's not here, but I'm saying people that have PhDs and so on have said many things like that indicate that there's more that could be discovered that could prove the paradigm incorrect.
I enjoy the conversation, and I've enjoyed the fact that I've been able to mature in my discussions and become a better person in a lot of ways by coming across people who diametrically oppose what I believe is true, and then being able to talk to them and not be an ass. That's helped me a lot. And I've met really cool people, a lot of whom are in here. Gio and I have you and I have talked for hours, and I've just really enjoyed it. And it's not politics and it's not anything else. It's something that's different from everything else, and that's why I enjoy it. And I've been looking at it since I first went to the FE 2017. Was that 9 years? Yeah. And I've had a jolly good time.
Which location was that? I forget where they all were.
Flat Earth Conference, Cary, North Carolina, in 2017. Met Robbie Davidson, Dean Odell.
Oh, that's right. Yeah, that's it. Yeah.
The whole name them.
I know who was there. Cool.
But when you add to that is interesting that you went to that for sure. I mean that's kind of shows something as well. I mean maybe even the reason they go to alien things is because I'm not saying aliens are real exactly the way they describe or that. Well, I think the abduction experiences those are real experiences. I'm not. What actually happened to them is a whole other question, but the experiences people have.
Yeah, like some people think that it's they're reliving their birth, like the big eyes and all that stuff. The light.
Yeah.
But a lot of it, I'll tell you what, I think a lot of the anti-flat earthers do it because they believe that flat earth is linked to the Christian faith, which they believe is harmful, and it links to faith or belief in things that are what they would say is demonstrably untrue, and that is dangerous. And so that's why they oppose it. If you talk to PhD Tony and you say, really, why do you talk to flat earthers? So he'll say, because these ideas are dangerous, these ideas are harmful. They'll use those two terms. Professor Dave particularly says that type of thing. And he attacks the Christian faith like nothing else. I still find him, I still think he's a genius. He's brilliant. He's a brilliant mind, but he's, he hates Christians with a passion. It's really funny. The other one is Aaron Ra. I watched one of the debates he had with Jaron, and he was quite effective in his arguments. But of course, Aaron Ra is no friend of the Christian faith by any stretch.
Well, the thing is, when you add the level of energy that's been of discussing this for the last 10 years, and then you add all of the ancient humanity that seems to have had the Earth as a stationary plane since the dawn of time, it's even more significant. Because what that indicates is that, like, we don't know how long humans have been here, I suppose, but it's probably like in the high 90th, if not like 99 plus percentile of the time that humans have been on Earth. They've actually had a planar stationary cosmology. And then the globe has come along in whatever recent time, depending how long you think humans have been on the Earth, it's either a fraction of a percent or I guess you could say it's more. Even if you went with like the 6,000 years, like early Earth thing, it would still be way more than 50%. But even if you're going to claim the 2,500 years, which I don't even believe that people all thought it was a globe back then either. Like if you'd walked around and asked people. So I'm just saying, like, the fervor of energy of discussing this and debating it and all the kind of allure that it has to many, that there's something to it. That's what I was more asking Gatebreaker. Like, is he able to detect, or what are his thoughts on, or anyone else either? Just like the sociological energy that has been involved in these discussions. And then when you link that to like the fact that humans have always had that cosmology, and when you link it that all of our spiritual and religious traditions that we're even into today all had planar Earth cosmologies as well. So like the entire spiritual lineage seems to have that as well, going back. And then the globe thing is heavily pushed by the government, which no one seems to ultimately trust, but then there's such a strong trust that people are defending models that they maybe can't fully prove that come heavily financed by the government entities, to say at the minimum.
I think the thing for a lot of Globers, there's the fascination of the fact that you have this group of people that are willing to believe something in the face of overwhelming evidence against it. And I think that's what fascinates a lot of the people that are in it, right?
It's the belief that you have overwhelming evidence, which you can't give none. No science. You say you have science, but then now y'all say science don't prove it.
Oh, yeah, like
you're really quiet for me. You're really quiet, man.
I mean, we got 60 years of pictures and video from space. We've got space-based technology and space organizations. Okay, but that's different. See, now that's a different. First, you said that there's no evidence, and then I said, "What about the 60 years of pictures and videos?
Yeah.
You know,
Where's the science?
testimony from highly valued members of society. You know, from around the world, from different cultures and backgrounds. You can choose not to say. You can choose and say, "Oh, I don't
Oh my
believe that
God,
evidence." But you can't say that that's not evidence, though, right?
it's
That's
not
just evidence.
evidence, dude. Yeah, well, I said science. Where's the science?
I mean, you know, the fact, you know, navigating the fact that we have a map that
Exactly.
you can use to navigate the globe that accurately
Is that science?
shows the relative locations.
Is that science?
Yes, it's
Yes.
science. It's understanding about the natural world.
Navigating the globe is science.
No,
Yes,
the fact that we have a globe, a model of a globe that we can use to predict the distances and travel times and paths and cardinal directions to traverse all the places on the earth.
I'm
It
still waiting
shows
for this.
shows that we do have science about the
No, it's not
composition of the
science.
earth, right?
Geometry. You've mentioned everything but science.
Okay. You notice that we shipped the original claim was that we had no evidence, and then I brought up
You have no evidence.
pictures and video, eyewitness testimony.
No
Those are all
science.
things.
Yes, I said you made the claim. You have science. You have no science.
Yeah, Jake, if there was science, couldn't you put forth that science, and science should be able to be repeatable, verifiable? Anyone could do it, right?
I mean, it is. I've always said, if they raised enough money to buy, you know, for FE Corps to do the $50,000 laser test, why didn't they put up a CubeSat with their own satellite that would take pictures and have an encrypted data stream with a private key that only they had, right? So that nobody could falsify it, right?
Images, not
So that
pictures.
nobody could fake it.
But the difference is the wording and the meaning. Okay, a picture, yeah, it's not an image. Okay, and
Just changing.
put.
Okay, but
Go ahead.
words don't. We know what the words mean, so we know what science means. We know that images, not all pictures are images, or it's the other way around. Not all photographs, not all images are photographs, but all photographs are images. So we have photographs. You could also call them images. That's
We're
evidence.
still waiting on the
and
science.
we've got a lot of the evidence.
The problem is always the pictures / images what they give us comes from the government.
Well,
there's private organizations.
Yeah,
There's people that have built rockets in their backyard and set them up high enough to take
How
pictures of the
can we
curved earth.
trust them? How can we trust
How
these guys?
high, bro? How high are those
It's not
guys taking
science.
pictures?
That's testimonies. That's a show.
I mean, private
That's
people
not
have
science.
sent up their own rocket above the Kármán line, right?
It's the Kármán. You think the Kármán line, dude?
Anyone made above the Kármán line?
I could bring up a mathematician, which he used to operate he was one of the head guys in the planetarium that NASA chose that guy to be supposedly one of the guys that went to Mars. Says that you can't even see it from the ISS, which is 250 miles.
NASA did not appoint. I think who you're talking about. NASA didn't appoint him.
What's his name?
It's about Neil deGrasse Tyson. He wasn't appointed by
Neil
NASA.
deGrasse Tyson, bro.
He was self-appointed. I don't think he was appointed.
No,
by
Dude, even if you do go up,
Tyson, does he own? Does he have a planet?
Even if you
is he head of a planetarian?
Yeah.
Even if you do go up.
Okay.
Hold on,
now
Red Cloud.
Hayden Planetarium.
You guys can't hear me? Even if you do go up and look at it, what are you looking at? You're looking at the horizon? That's the flat part of the globe.
Go higher.
You go higher, you're looking at the flat part of the globe. It doesn't going higher doesn't make you not see the flat part of the globe.
I don't think you. Okay. Hayden Planetarium is what I was trying to say. That's the planetarium that Tyson runs. Again, he is also anti-Bible, anti-Christian. Just so you know. So he's not my friend in that way, but he's not wrong about the shape of the earth and not wrong necessarily about the things he says that he has within his purview, within his expertise, right? I'm able to sort the two things out because I've got the point where I'm like, okay, people are just anti-Christian. That's just how it is.
All right, tell me how high you go before the horizon on a globe isn't the flat part.
10,000
What's
miles.
the height? Nope, still the flat part.
It's 20,000 miles.
Still the flat part.
250,000 miles.
Bro, let me give you a little tip. As high as you go, it's always the flat part. The horizon is a plane on a globe.
It's not. When you get far enough out, you go 100,000 miles out. You look at, you go, yeah, it's a globe. I mean, that'll happen if you do it. The thing you have to do though is you have to beyond a certain height, you have to
The
declare it to
problem is
be
this is against your own globe model, your geometric globe model. Okay. We are able to see the curvature at 40 kilometers altitude. Okay, according to this geometrically mathematical globe model. Okay, and what we see without Fisher lenses is not a curve; it's a flat, level curve.
So, are you going to say you can't go any higher in order to avoid? Because what it sounds like, I'm not being critical, but I am being critical. It sounds like that what you're saying is there's this height at which the Earth is going to appear flat, but we don't want to go any higher because we run the risk of finding out that there's actually a curve. And so beyond that height, we're going to say that that's all faked. Anything below there, that's all legitimate. Anything above that line, whatever it is, which starts to show a globe, then that's all got to be fake. It's all got to be the government. And if it isn't the government, it's just fake anyway.
The problem
that
is
sounds like the whole.
We can send public an altitude balloon. Okay, that's what we can do alone publicly. Okay, but everything else, it's trust to the government or the space agencies.
No, that isn't true. That is not true, because you can have people like was it Jake who said private people have gone up and seen stuff, sent stuff up, and you can too. You can crowdfund. I've said this before. You could crowdfund, get all the flat earthers together, and I don't know how much money each, and just all crowdfund a rocket, or what was it you said, a satellite or something?
I said a CubeSat. You can do a CubeSat for under 100,000. I mean, they spent 50,000 on FE Core. 100,000 isn't some unreachable target.
Yeah, FE Core did it. FE Core raised a considerable amount of money. You had to do that, and you would see for sure, and you could decide one way or the other. So why not? What about it, guys? And if the government won't let you do it here, go to Kazakhstan. They'll let you do it there. Who's with me? Everyone cheer at once.
He brought up 40 kilometers. That's about the height of a weather balloon. And Dwayne Kellum, he was a flat earther. He went out of his way to put up a rectilinear camera that showed curvature. Rob Skiba, before he died, put up a balloon with a rectilinear camera that showed curvature.
What's curving?
The horizon was curved.
Yeah, but that's geometrically that's flat on a globe. Your flat part on a globe looked like it was curving.
So what would you?
If I hold my camera above a ball, I see a curved horizon. Do I not, or do I?
Get a beach ball.
Yeah. You got a curved horizon, yeah. But that's geometric.
And if I hold my camera over a flat plane, there's no curve, right?
No, well, there would be a curve if you could only see so far. So yes, there would be a curve.
On a flat Earth, the horizon would be curved.
Yes, because it's a circle around you. You could see 3 miles in all directions, right? If you're a 6-foot observer.
That's not a curve.
But
that's a circle. That's the same. It's the exact same circle you have going on with the horizon. It's the same circle, bro. It's a plane. It's a circle on a plane.
The dip is more severe on the globe. The dip. Once you get up, the dip.
It's not silly, dude. You have a flat plane on a globe.
Say silly. I just said
of the horizon. I'm responding to Jake.
Oh, okay. Sorry.
I thought you were done talking. You're still talking? Go ahead and I'll respond to Jake.
Please go ahead, Jezek. Please go ahead.
Yeah, on a globe, you have a horizon that is a flat plane. For all intents and purposes, that last bit of land or water you see is all on a flat plane. On flat Earth, guess where that last bit of land or water is? All on a flat plane.
Yeah, except for the fact that I can hold my camera over a beach ball, it'll show curvature. And if I hold it over a flat table, I don't see curvature.
I could hold it over a hula hoop and you see curvature now. In fact, the more higher you go, the more curvature you see with a hula hoop, which is the flat plane. It's the same exact thing on your ball. You can put a hula hoop to wherever your horizon is. And that's all you're referencing. The edge, you have the same thing flat Earth has. You can't just look at it and be like, oh, it looks curved, because it would look the same on a hula hoop as it did on a ball.
Well, the question is, what on the flat Earth would cause you to see a hula hoop?
You can only see so far. You can't see forever.
Okay, but a hula hoop has a distinct curved edge where the image of the hula hoop ends, right? And then some other image appears beyond it, right? That's how you know the edge of the hula hoop,
yes,
right? Like if I take a picture,
flat Earth.
If I ever take a picture of hula hoop on my grass, the hula hoop ends where the grass begins, right? So on a flat Earth, though, what's causing
and
the
on
hula
flat
hoop
Earth,
edge?
I'm trying to explain it to you. You won't stop talking. I know you already asked. That's the second time you asked. You can only see so far. And I already told you the answer to this too. Something's happening, some optical effect where you can only see so far. And that's the last bit of ground you can see. Now you got your hula hoop. There's no differentiation between just looking at the horizon and say, ooh, it looks like it's curving from a globe than a flat plane, because it's literally geometrically a flat plane on a globe. That's what your horizon is.
So if that's true, when I take video and I take a picture in the fog, if I take a picture in the fog where I can only see so far before the fog, blends everything to white noise, then that should be curved, but it's not. Pictures in the fog don't show
can see a circle,
a curved horizon.
You're
only seeing a circle around you, right?
Wait.
If you have an equal distance to the amount you can see around you, and you go above or below it or whatever, that will start looking curved like a hula hoop. Yes.
Okay, show me a picture in the fog.
It's not if what I said is true. Hold on, Jake, real quick. One second part to my response to you. Not if what I said is true. Everything I said is true. It wasn't an if.
We should be able to we should see a curved horizon in the fog then, because you'd only see so far in each direction. You can only see so far in the fog, right? Like, the visibility is only 500 feet or 1,000 feet in the fog. That's a circle around you. That's 1,000 feet away in which you can make out things. And then beyond that, it's just white noise, right? In the fog. So therefore there should be a curved horizon in the fog, right? You should be able to show me a picture of a curved horizon in the fog.
If you were to get above that and the last bit of ground you could see before the fog started, and you could see an equal amount in each direction, you have a circle around you. Yes, that would be curving, of course. When you get above a circle, guess what happens, Jake? Guess what happens when you get above a circle?
Hey, show me a picture in the fog with a curved horizon.
It's not even relevant. It would have to happen because when you're above a circle, bro, when you're above a circle, it starts curving. You can go test this for yourself. Get a hula hoop, line your eyes up with it. It'll be flat. Go above it. It's curving now. Now you can see the curve because you're above it.
No, because the hula hoop is actually curved.
Yeah, and so is the ground you can see in the fog or not in the fog. The ground you can see around you is also a circle. It's curving.
All right, show me a curved horizon in the fog. It should be easy.
Bro, if it's a circle around you, you can just go do it yourself with a hula hoop.
I think we're talking past each other.
We're not talking past each other. You're trying to bring fog into this.
You see curvature in the hula hoop because the hula hoop is actually curved, and we have a distinctive edge in which the hula hoop ends and some other background begins, right? If I'm taking a picture of the hula hoop over my grass, there'll be a contrast between my green grass and my pink hula hoop, right? And the hula hoop is actually curved. You're saying that that's akin to being in fog where you can only see a fixed distance away from you in every direction, depending on how thick the fog is. If it's really thick, it might only be 50 feet in front of you in all directions, right? So then what that means is, according to you, then there should be a 50-foot circle as if we're standing inside a 50-foot hula hoop by which you could hold your camera and see a curved horizon like a hula hoop in that fog, which is just ridiculous because we both know if you're standing in fog where you can only see 50 feet around you, you're not going to see a 50-foot hula hoop around you because the fog is not, your visibility that you can only see 50 feet is not the same as the physical hula hoop that is actually curved and has a contrast with the color that it is, right?
Man, okay. Are you gonna stop? Are you gonna stop so I can respond? So if you did have fog, 50 feet around you, and the last bit of ground you could see was 50 feet around you, and you went and put a hula hoop down, you've been like, "Yup, that's the exact spot. I can't see the ground. That's the last bit of ground you could see." That ground, if you are above the hula hoop, will in fact be curving. It will optically be curving, even though it's on a plane. It'll optically look like it's curving, even though it's flat.
Yeah, you're just seeing in a circle.
Like, I don't know why you're trying to debate me on this. That's just facts.
I mean, okay, go ahead and show me a picture in the fog where you can see the ground and thick fog, and show me the circle that's like a hula hoop in the ground.
Okay,
And
that's
what you're saying is true. You should be able to
Everyone
find
can go
pictures.
check
There's
this.
fog all over the earth every day, right? So there should be a picture of what you're showing, which is that you can see the ground, you can see where the ground kind of just blends into the whiteness of the fog. You should be able to see a hula hoop in the fog, according to you.
I did. I posted it.
All right, and anyone can go check this. Anyone can go check this for themselves. If however far you want to pretend you can see for, and you do a circle that big. Brandon actually did this one time. I think he did a 50-foot circle around him. And when you come above the circle, it looks like it's curving because guess what? It is curving on a plane now. Go ahead, Beasticles.
Don Geo used to call this rim curve.
I was just trying to ask Jake, where the flat Earth, can he point to where the flat Earth touched him?
Right on my pee-pee, dude.
Jake, I posted a picture for you. Yeah.
Can
so
I?
you wanted, right?
Get on?
Where's it posted?
In live stream text.
Like the fact you're even trying to debate, the fact you're trying to debate me on this is very telling, and we're this far into it.
Where's the timestamp?
5:09. Oh, you mean in the video?
Wait, are you talking about the Dwayne Kellum thing?
Yeah, you wanted to see the circle.
So
right?
let's do let's find the original source of that video and let's just do.
Go ahead.
Okay. Do you know the original source of that video?
Yeah, I'm watching it. That's how I got the screenshots.
Okay. So is it your contention that I can't find any spot in that video where I can take a screenshot, draw a line in paint, and not show curvature, not show excess curvature bulge in the middle?
What are you even asking?
Is that your contention? You're saying that it doesn't show curvature. So does that mean I can take that video and at any timestamp along that video?
Didn't say that.
So
I said
are you
were demanding Jeremy provide you evidence of the hula hoop kind of effect that you would see, right? Where you would see fog and then the ground would be a circle beneath you, right? Like in the fog.
Yeah, but in the Dwayne Kellum video, the reason why we're seeing curvature there is because the earth is curved. You're seeing the curved horizon, not the effect that Jeremy is talking about, which was I was talking about.
Do you not realize
in the fog? Hold on, Jeremy. I'm still talking. In the fog, where we know the ground is flat, we're going to be able to outline a curved horizon because of our limited visibility of fading into the fog, right? Not what you're showing me in this video, which is, I believe, a curved horizon.
Okay, but Jake, I figured out what your problem is, though. You don't know that the horizon on a globe is actually in a plane. That's flat. You realize that, right?
Yeah, And that curvature that you see.
Hold on, bro. Hold on. Let him answer that because that's where this whole problem is at. Jake, your globe, the horizon, that whole thing lies within a plane. It's flat.
I don't know what you mean. You mean like if you take a slice out of an orange, that's a plane? I think that's what you're referring to, but that's not what we're seeing when we're above it. We're not seeing the slice.
No, let's say you were on a ball, hypothetically, let's say you were on one and you went up at altitude, you're at 1,000 feet, 2,000, whatever it is, and there's an angle to the horizon, 360 degrees around you. Again, hypothetical, we're on a ball, you're on a globe, you go up high. It's an equal angle, 360 degrees. Let's say the conditions are fairly clear, so you don't have all kinds of cloud cover. You have clear conditions. To the horizon is a 360 degree points all the way around you, and your angle is equal from your eyes to that horizon at all 360 points. Those 360 points, or the 360 degrees of all those points, are all like a hula hoop, and those points are coplanar with each other. So the points on that horizon line, what you're looking at, are all coplanar to each other. Like if you put a hula hoop on the side of a ball, is what you're actually looking at. So you're not actually looking at any left-right curvature. Even if it was a sphere, you're looking at all coplanar points all the way around you. Therefore, any left to right curvature cannot be interpreted to be exclusive to a sphere whatsoever. And in fact,
and by the way, that's not always the case. David Cullum sends more than one altitude balloon. Okay, and over 40 kilometers. Okay, he has 2 balloons that show a flat fucking horizon, and they use exactly the same lens. Yeah, a flat rectangular lens. Okay, and to mention a rectangular lens has an distortion. Okay, it's really small. Okay, yeah, but there is a distortion. Okay, and 2 times of his altitude balloons they don't show curvature. Okay, that's not always the case. That's absolutely wrong. And if I create other lens corrections in a geometric sense, okay, we can go up to 100 kilometers, we can go up to 250 kilometers, yeah, from a rocket, from the DSLR, okay, there is no curvature. None.
It is gorgeous footage, by the way.
I think where Jeremy is getting lost in this whole analogy of the hula hoop and equal distance is he's not considering the fact that when we're looking at the curvature from high up, we're looking down in the same way that you can't see the curvature of the hula hoop when it's directly in line with our eyes, right? It just looks flat if it's in line. But when we rise up and we're looking down, we're seeing the curve, and the same reason why when we're looking down on the earth from above and we're looking down at an angle, we're seeing the cap of that earth, right? Like we're seeing the curved portion within our vision.
When have you ever done that, Jake? When have you ever had to look down at the horizon? Ever?
What do you mean? What do you mean? I've done that
Jake,
test. I did that test.
Yeah, if you want to talk,
I did that.
I want to clarify.
You asked me a question. You said, when have you done that? You asked me, when have I done that? And I was going to tell you exactly when I've done that. Can I tell you about it?
You've had 10 seconds and you haven't told me shit. What the fuck is your problem, Jake? Why couldn't you just answer it instead of going on with the monologue?
You said you've never looked down to see the horizon, and I was going to tell you about the thing that I did where I had to look down to see the horizon.
You had all this opportunity, you still haven't done it. What the fuck is your problem?
Okay, I went up to a top to a spot on the top of the Santa Monica Mountains, right, called the top of Stunt Road, where you can see the beautiful panoramic view of the Los Angeles Basin and the Pacific Ocean. And I set up a copper tube with a 1/2-inch copper pipe that I perfectly leveled on a camera tripod, and we looked down through it. And when it was perfectly level, you could not see the horizon. You had to angle the tube down by 0.7 degrees in order to be able to see the horizon from the tube. It had to be the tube had to be out of level. The tube had to be out of level, pointed towards the ground, dipped down by 0.7 degrees because I had a machine DRO, which is like a digital angle finder, in order to be able to see the horizon.
But yet, when they go up 160,000 feet, they're still looking straight out, and the horizon.
No,
is right at eye
dude.
level.
Yeah,
No, go
he's
look.
trying
Go
to
look
say
out the
there's no
window.
dirt and water underneath where his tube's pointing.
Dude, when you look out
That's
the
clearly
window
false.
on a plane, you can clearly see that you're looking down to see the horizon. I mean, the horizon is not straight ahead of you. It's obviously a few degrees below you when you're in a plane.
Is the Earth still below you no matter how far you look out that way, though, through your tube? When you take your eyes off the tube and look back, isn't there Earth out there still?
I have deep on
So
you.
the
I
Earth
can see
is
he's
still out
talking,
in
but
front
I
of
don't
your
know what he's
tube,
saying.
regardless whether you're looking in your tube. The Earth still goes that far, regardless. You haven't proven the Earth stopped anywhere. So cut your tube out. Unless you make a tube the size of Earth, not the size of Earth, but the size of the, what you say the Earth's 3959 or 7,900, whatever it is, and line that up against our horizon. Then we'll take a peek at your tube.
Yeah, I mean the left to right curve effect can occur optically. The question is that in any way exclusive to a globe Earth the way the globe Earth folks claim? The thing is that also like Dong said, sometimes it doesn't have that effect. I think it depends on the atmospheric conditions. Because if you're up really high and you can see really far, you're not going to have very much. You're not going to have the same limit of the ground as you do when you're on the ground. When you're on the ground or closer to the ground, you're going to have often a much more earlier limit of where the ground is. And that also can be more consistent, like a cookie cutter, in some cases like a circle. Whereas when you're at high altitude, you can have this breadth where you can see much further, and you can see more of the extended plane without that same limitation of the angle. Of course, you do have atmospheric limitations to some extent, but those atmospheric limitations are in a ratio compared to how high you are above the plane. So those conditions based on that ratio, and as you get higher and higher, it does seem like from some of this footage that ratio changes to the point where you can see further of the plane than you would otherwise when you're on the ground. And then the conditions are not so bad that it's equal to that. Like the more you can see are not made equivalent to the more blockage from the atmosphere. So there's like less blockage from the atmosphere and you can see further, then you won't get that effect of seeing that kind of left to right effect. But even if you are seeing that left to right effect, that happens over a plane when you have that limited distance that you can see. And like Jeremy was saying, even if it was a globe, you would still be seeing coplanar points like a hula hoop around you. So that wouldn't even be exclusive to Earth curve. It wouldn't even be interpreted as Earth curve. It wouldn't even be Earth curve. Even if you were on a globe, that wouldn't be. Now, if you went out potentially far enough to actually see it as a ball, that would be different.
No, I'll debate you on that one. But still, though, it's just a plane. If you're only referencing the outer edge, it's just a plane. That's it. Like all these debates we've had.
Yeah, but if you went all the way out to where you're seeing, if hypothetically it was a sphere and you went all the way out and you saw, now you're seeing the equator as that circle. Well, that actually is the contour of the curvature of a hypothetical sphere.
It's still on. I'll debate you this till I die. It's still on a plane. You put a hula hoop on an equator. Right? You put a hula hoop on an equator.
The points are on a plane, but they're following the curvature of the Earth at that point. If it was curving.
So it's I don't know. I don't think so. I'll debate you. I'll die on this hill. This is the hill I will die on.
Is it a curved hill?
We'll see you in the next life then.
Wait, so Jeremy, question. So if you're zoomed in all the way to a basketball and then you zoom out, you wouldn't be able to tell the circumference of the ball? Is that what you're trying to say?
I'm just saying on a ball, if you're only referencing the horizon, that's just a plane. Even if it's the equator or a little piece of it, it's on a plane.
Even if you saw just the top half of the ball zoomed out, you wouldn't be able to tell the circumference of it? Even if you just saw half the ball, that wouldn't be the outline of the actual ball?
It would be the outline of the actual ball, yeah.
Exactly. and
It's
that's
still on a
how
plane. Okay, it's still on a plane though. Exactly. It's still on a plane, right?
Those points are coplanar, but in that case,
Yeah.
they follow the contours of a circumference of a sphere.
Yeah, I hear you. If it was a ball, that would be the curve. If not, it's not. But either way, though, it's still on a plane.
Can we discuss this photo I just posted? It's 118,000 feet up. Where would you say the horizon would be?
Pretty blurry. The way they say that it would look if it was a plane, ironically.
That is exactly how they describe a horizon on flat Earth. I know, ironically, that they say, "Oh, it'd get fuzzy." What? Just like that?
Your premise is our conclusion.
By the way, this is from a video game real quick I'm posting, but it shows like a planar grid, and you can see how it has that left to right effect, even though in the game it's just an extended plane. But there is a limit of the pixels of how far that it will, represent, which is kind of similar to like the limit on a plane if you can only see so far, due to optics. But it kind of shows that effect. But it's like rim curve. Don Gio used to call it rim curve. Remember that?
No, we used to call it the circle of light, and I used to roast them all the time with the Disney, with the Lion King shit.
You know what's crazy? Oh, about that video game and the video game aspect in terms of like physics. The more polygons you have, the more realistic it's going to look, right? Well, they figured out that it's actually better with triangles. So it's not polygons anymore in terms of like 5-sided, or I think it was 5-sided, but you use a little
Triangles.
tiny.
We did this yesterday. Triangles would be the best pixels to have because we're talking about hexagon pixels and square pixels, and some guy came in saying triangles.
Yep, they call it nanite virtualized geometry. And it uses triangles essentially. These triangle meshes.
Like Jeremy's icon.
Nah, that can't fuck them out. My icon's too deep for that. Yeah, bro. Any ball. Hold a ball in your hand. Golf ball. Get a golf ball. Look at it. If you just reference the horizon, that shit's on a plane. That's planar. Co-planar points, right? Bro, I figured this out years ago in Brandon's. He was debating Mr. Sensible on blue magic. What was the blue mage? Something. They sent up a high altitude balloon. Brandon was debating him on it. I'm like, yo, because Mr. Sensible was like, why is it curving? And I was like, yo, why is it curving? And then I was like, oh, if it's a plane, it would still be curving. And then I went and set up some bottles of cleaner at work, made a circle out of them, took a picture from the bottom, got up a little higher, took a picture, you know what I'm saying? Showed that it was curving, and it's just on a plane now. And that's when Brandon went out and did a 50-yard one or 50-foot one or whatever with string and some posts and shit. And it was like, yeah, it's curving.
The thing is, it doesn't happen. Yeah, the one thing that's not exclusive to being a globe, even if someone was to claim that, is that like this shot I posted right here, that's just like a perspective matrix grid. That can be more what it looks like at high altitude because you can actually see, because the planar grid is not curving itself. It's just the limit of how far you can see can create a circle effect. But when that circle effect is not present, when you can see left to right a lot further, then you get the actual planar grid. It's like reveals what it actually is when you don't have that limitation of the ground being at a closer distance when you're closer to the ground or when the conditions are more limited. Like if we could see forever in the atmosphere, as it were, the environment had no blockage, then it would never have that left to right curve. It would always look perfectly horizontal and straight.
Yeah, I don't, it just makes way more sense that what we do see in reality matches plane because you have more compression because there's more things in between you and whatever you're viewing. If you're on a ball that's curving, has drop over distance, then you're going to be looking through less and less atmos the farther you look out into the distance. So you would expect to see less turbidity, like less attenuation of light, because you're looking through less atmos if it's curving down. But that's not what you see.
You'd see, like, if it was curving, you would see more of the curve at higher altitudes and less conditions, and instead we see like more of the plane. Like
Yeah,
it's more
exactly.
of the planar geometry. Yeah.
But even not even just in altitude, just like in general, if you're looking out into the distance at the horizon, you would expect to see more. You would expect to see further on a ball in terms of like, you expect to see further on a ball in terms of the clarity of like the air. Like if you were following a plane, for example, okay, let's say you're following a plane, it's flying over. You're on the beach, you're looking over in the ocean, plane's flying overhead, and it's going straight down, past your head. Now you can see it. It's going towards the horizon. It's going towards the horizon. You would expect to see that plane more so than you would see like on a ball necessarily because there's less atmos in the air. Does it make sense? It's hard to explain. I'm trying to put it in words, but I just feel like the simple fact that we have the amount of compression that we do at the surface makes way more sense if it's planar. Like why you're like why you see more things when you rise in angular or raise in the altitude and the angle increases, right? Like, oh, I could see more stuff. Now I'm getting higher and higher. Like if it was on a ball, it was like there'd be a certain cutoff point, and then all you would see is just air or like the atmos. But I don't know. You never see it. Like 119,000 feet in the sky is just apparently not high enough to see the curvature. Yet, you're supposedly seeing the curvature right here on the ground by watching a boat go over the horizon. It doesn't make any fucking sense, dude.
Yo, hexagons are the craziest shape, bro. Eli just posted a thing of V's and a honeycomb, and I just happened to be shopping for some Wu-Tang Air Force Ones earlier. But a hexagon is the craziest shape because honey is the dopest food out, and it's grown in a hexagon.
I think triangles are way crazier.
If you had 3 triangles, you make a hexagon.
Yep.
Or more.
Is it 3? That was 6.
I don't know. I like them.
You guys hear
what you can get a cube. You can get a cube to look like a hexagon too. Isn't that a weird thing? You spin the cube at a certain angle, you're like, oh man, there's a hexagon.
I think
if you start spinning shapes, if you start spinning shapes, bro, it gets crazy. With shadows of shapes that are spinning.
I still think triangles though are the craziest because if you think about like what is the strongest support structure? Triangles.
Are you sure? Yeah. Beast, you want to get your mind blown? Go watch Spirit. You're straight? All right.
I'm just kidding. What? No.
All right.
Watch Spirit. What?
Nah, you're good. You're good.
Okay.
You don't want to get your mind blown.
Maybe
don't
not
try
right
to fake
now.
me out from faking you out from faking me out, bro.
Listen, I'll get my mind blown later. Give me something to blow my mind later. All right, what is it? What? Watch
Give him a
Spirit. What?
coupon for mind blowing.
Yeah, yeah.
It's called. Write this shit down. You're gonna want to write this down. You got a pen or something, notes in your computer, Windows.
I'm not a boomer. I'm just gonna type it. What is it?
Use a stone.
It's called Spirit Sciences, Sacred Geometry, the movie. Sacred Geometry, the movie. Straight fire, bro. That's the craziest geometry thing I've ever seen in my life, bro. That shit is intense and deep. It's thick. Shit is thick.
Hey,
you're gonna need to take notes. You better get a pen.
Okay. The first, literally, I just popped it open. It says
It's like a intellectual version of Megan Thee Stallion.
Dude, the first quote in the movie or whatever, it says, "Don't believe or disbelieve anything we discuss in spirit science." Is that it? I post it.
So what happens in spirit science stays in spirit science.
That's it, dude. That's fucking it. Is it like 2 hours long? An hour and some change?
Yep. All right, I'll save it for later.
You're gonna want to watch that probably 5 times in a row because 6 hours doesn't count, Beast.
Jeremy is just trying to shape my mind.
No, that ain't enough, bro. 5, that's rookie numbers. This is on the same list I got the Karl Monk shit on, bro. You're gonna need to watch this dozens, if not hundreds.
I'll watch it later, but can somebody send it to me, please? I can't go into the chat right now.
I'll send it to you, Rob. It's gonna
Watch
cost
all the
you.
secrets in plain sight.
Don't send it to him. Don't even send it to him, bro. Make him suffer.
Come on, Jeremy, why you gotta be such a hater? I did this for you.
You're gonna watch all the secrets in plain sight. We're gonna put you in a Clockwork Orange chair. You're gonna love it.
Can I get a venti London fog?
Rob, you're hot micing.
No, that was me.
No, that's the greatest part about that soundboard is that it sounds like he's hot micing and we can just move to the hot mic room.
Please with no water, no room, no foam.
It puts the lotion in the basket, or else it goes into the hot mic.
You know what, Rob? You know what you earned today?
Extra pump of vanilla and extra hot. I didn't hear that. Usually I say please at the end, not I didn't hear that.
All right, you want to get your mind blown right now, bro? You want to get your mind blown, Beast?
Call him Beefticles now.
Trying to blow my mind twice, dude? Dude, relax, bro. Take it easy.
You want to get your mind blown? Here, I'll start you off light with a joke, and then we'll get into the mind blowing shit. You ready?
All right.
You ready for this, Beast?
I'm ready.
All right, what's the difference between a hormone and an enzyme?
Hormone and an enzyme. What?
You can't hear an enzyme.
I knew it was something like that. Couldn't remember how it went. All right.
Now, how many times do you think the number 7 appears in all of the numbers?
That was a good one, Jeremy.
Whole numbers, all the whole. Settle down, Rob. Put him in the hot mic room. How many times do you think the number 7 appears in all the whole numbers?
Well, 7's a holy number, so I wouldn't be surprised if it's like everywhere.
Everywhere?
Yeah, you got like 7 continents, 7.
No, just in the numbers, in the list of numbers. I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All the numbers. How many times is a 7 going to appear in a number? Like, 37 or 71 or 764. How many times do you think 7 appears?
Isn't it once every placeholder? Pretty much? Twice? I don't know. Dude. I don't know. What is it?
All right. How many times is the 7 and one go 1 to 10? How many times does 7 pop up?
1.
What, one.
You
got
better
one
start holding
seven.
your head because it's gonna explode pretty soon, Beast.
Yeah, your shit's about to be damaged. Spontaneous combustion.
I already feel damaged. We'll get on with it, Jeremy. What is it?
1 to 10, the 7 comes up one time, right?
Yep.
But 1 to 100, now how many times does the 7 come up? So we're at 10% with the first one. Now we're going to go 1 to 100. How many times does the 7 come up?
Oh, wow. Okay.
You got 7, 17, 27, 37, 47, 57. And then you have all the 70s too, though, right?
Yeah.
It's way more than 10%.
Okay. I'm with you.
It's like 19 or something. Then you do one. Then you do 1 to 1,000. Now, how many times do you think a 7 pops up? It's even more than the last one. And every time you do that, it keeps getting more and more. 7 is in every number.
It's in every number? What do you mean?
Yeah,
every
7 is in every number.
Doesn't make sense. How is it in 36?
Say it again, Beast.
You just said it's 7's in every number, but how is it in 36? I don't know what you mean by it's in every number. What do you mean?
Well, that's the only exception. Like
No, I
every
mean,
number
there's
but 36.
36 chambers. Here's the thing. Did you see the thing I just brought you through, though? As you keep going, you go 1 to 1 million, 1 to a billion, 1 to a zillion.
The
If
amount
you
of
keep
sevens
doing that, yeah, if you keep doing that, it just keeps going up and up. You'll never actually get to 100, but you'll get like, you can basically do 99.9 repeating. You can make it so it never ends. And 99.9 repeating is what have we all been told?
Yeah, but why is that special? Like, can't you do that with 4 or 5?
Every
Or
number.
6?
No, it works with every number. Yeah, that's the crazy part.
Yeah, I feel damaged.
Was your mind blown?
No.
You try some icy hot on that.
Jeremy, come on.
That's not neat. You're telling me that wasn't neat. That thing we just did.
Bro, I'm retarded and it wasn't good. Sorry, like, yeah.
I don't think he got it because when he said you said on every number, he said what about how is the number on 36? How is 7 on 36? I don't think he got that part. But what he meant by on each number is by the 10s, the 20s, the 30s, the 40s, the 50s, the 60s, so far and so on. The 7
If you
is
keep
in each
going,
one of
it's
those
just be
numbers.
99.9 repeating. Right? You just
Well,
keep
he's
going
saying that
forever.
the amount of 7s or the amount of any number increases percentage the more you go out.
Jeremy,
Yeah,
you're
and if
gonna like
there's
this.
an infinite amount of numbers, you're at 99.9 repeating. Go ahead, Beast.
I have the physical book I found at Goodwill. Right? It's called Math Magic. And it's from Scott Flansburgh, The Human Calculator.
I thought that was
Dude, I
Homer's
had that
neighbor,
exact same book. I had that exact same book in a place that I rented in Canada. It's so crazy.
No shit. From like 1993 or whatever.
With the wizard on the front?
No. Here, I'll take a picture of it. It's definitely from 1993. But Scott Flansburgh or whatever, basically, in this book, he teaches you how to completely rework the way you do math. Like, for example, all right, if you give me, a single digit percentage of any double digit number, just keep it whole numbers. I can give it to you real quick, like super quick.
All right, 5% of 20.
That's easy. It's
This is not
1%.
super
That's
quick,
one.
bro.
That's
Super
one.
quick.
That's one.
Super
That's
quick.
one. It's one. It's one.
No, it's not 1%.
Beast. You said you
Hold
could do
on,
it super quick,
Do
and
it.
now you don't even know
Give
the
me
right
another one.
answer.
Give me another one.
5%
of 20 is one. I'm so sure of it. I'm
You failed,
absolutely
Beast.
certain that 5%
Yeah,
of
it's
20
one.
is
It's
one.
one. It's one. Yeah, it's one.
You
Give
already
me a
failed,
hard
bro.
one.
You did.
It was too easy. I didn't get to do the trick.
All right, 5% of 40.
Stop doing 5%.
That's
Why?
two.
You told me any number. You are at. This is an
Be
epic
like
fail, Beast. This is
8% or
worse than the
something.
thing I just did. This is
Be
way
like,
worse than what I just
give me
did.
a
No,
But
dude, I'm
fucking
pretty
weird
sure I
one.
had the exact same book, bro. It's just maybe the cover was different for me, bro. But I remember it literally being like having that trick
Probably.
in it, bro.
Come on, Jeremy, give me a
all
hard
right,
one.
8% of 56.
Okay. That is 4.48.
That's not right.
8% of 56?
Is that right? Is that right?
I don't know, look it up. Yeah, it's right.
Sounds right. Sounds right to me.
Yeah, so what you do,
How'd you
instead
do
of
it?
56, I'll show you. Okay, so instead of going from right to left, you go left to right. So 8 times 5, 40. 8 times 6, 48, but you put the 48 on the other side of the decimal. 4.48.
Wait, what?
Yeah, all right, so 9%
What did I
of.
even say? I said 8% of 56.
Yeah.
No, he
8
just
times 5.
multiplied the numbers by each other and then moved it over to decimal places, which makes complete sense.
Yeah. So like 7% of 32, right? 7 times 3, that's 21. 7 times 2 is 14, but you put the 1 4 where the 1 is, so that would be 2.24. That's 7% of 32.
That's a Nilo trick.
Yo, this
that I'll
is
probably
shit that
never
This is
use.
shit that Wes could never understand. Yet somehow he's an engineer.
Yeah, I guess. I mean, he's not here, but all right.
Nah,
Ready?
dude,
Ready,
I
Noah?
quizzed him. He can't do basic. He can't do basic arithmetic, dude.
8% of 54. Go.
8 times 5, 40. 8 times 4, 32. Was that 72.72 or something? Or
Nope.
did I
Now
do
you
that
fucked
wrong?
up. Yep. 8% of 42. Or what did I say? 52? 8% of 52.
No, wait. Okay, wait. It's 4.32.
Yep. That's if you do.
Yeah, sorry, I put the 40 one digit back actually on accident. But yeah, 432. Let's go, baby. The magic number.
All right, Jeremy, come on. You get it now? I know you're driving, so this is fun for you.
I'm driving as well.
There we go. All right. Do 4% of 77. It's a little this is a little hard.
308, 3.08.
Nope.
What? Did you say 4% of 77?
Uh-huh. Oh yeah, you're right. You're right. Oh, I thought
Yeah,
it was
get the fuck out of here.
4.
You never
Noah
beat
gets
me.
it.
Dude, I tell you, I'm naturally really good at math.
We slow roasted you on Infinity the other day, though. Just remember that.
The slow roast.
Yeah, so the numbers we use, Jeremy, this will probably be cool for you. 1 or 0 through 9, right? 0 for 0 angles, 1 for 1 angle, 2 for 2 angles, 3 for 3 angles. In terms of like why we write it out as 0, as 1, as 2. 4 for 4 angles.
Oh, I've seen that where they break down all the numbers and they have all the angles inside of the numbers.
Yep. Yeah, and then like, what else did he do? He did something. It's interesting.
I got one for you, Beast. This one's pretty groundbreaking. Name any two numbers off the top.
11.
1 and 2.
I've heard of both of them. Fucking bam, dude. What do you got? Nothing.
I didn't think it was going to get any worse than what we've been doing, but it did.
What, you got two more numbers, dude? Throw down two more.
How do you know there's a 23-degree tilt there? Doesn't that mean that a plumb would either be off by 23.4 or plumb would be 23.4 degrees at that point? Isn't that what plumb would be on a ball, like sticking out that way? How do you plumb the 23 degrees, 23.4 degrees, facing exactly to the sun? That would be like your high noon. So your high noon on Earth is 23 degrees? That's weird. So your vertical is already 23 degree tilted? Huh. Explain that one. 23.4 degree tilted straight plumb on a ball. Pointed right at the sun. Boop. Sweet 23.4 degree tangent line. I love it. Where's it at? Where do we poke that boy in?
All right, well.
Was I cutting out?
No.
So how would a glober go about proving that his 23.4 degree tangent is horizontal or vertical or well, I mean, what does that even mean? How do you prove that? How do you prove there's a tilt there versus a non-tilt? I'm looking at the flat ground below me. I've got a line between my legs. How do I know that's a 23-degree tilt? That's weird. Compared to what?
Let's talk about the
Jeremy,
axis. What's
Yes.
up,
I sent,
Beast?
Yes,
I sent
sir.
you a video that explains eclipses.
On a flat Earth.
You see it?
It explains them on a flat Earth.
Just in general.
Has it got
Is it
Rahu and
Earth
K2?
agnostic?
You see it? I'm scared to post it in the live stream text. It's a
Dude,
real
don't post
song,
that.
dude. I
Don't
didn't.
post that.
Dude, that's a real song title.
What do you call a black guy on the moon?
An astronaut.
Yeah, that's it. That's it. Definitely not what Beast sent me.
Oh no, don't do that.
Bro, it's a good song.
Is it really? Is it a rap?
No, it's like ragtime. Like if you were in like a saloon.
That's funny. I don't even
You
know
ever
the song, and that's funny.
I'll send it to you, Demog. Dude, it's Foundering. Remember Foundering?
Yeah, it's like a guy. This would be something getting played by like a guy in a saloon at the piano or something.
But dude, he does all the different types of songs. They've never been sung before. In terms of like modern times, right? Like, and there's entire archives in Congress that have all of these songs, like that are called ragtime. There's some funny names. Let me just say that.
Were they like banned or blacklisted or something? Like,
No,
no, just regular ones. People
but
nobody
they
heard.
would
That's
be
fine.
because of the names of them. They
Oh, okay. Well,
definitely.
that's what I was getting at. Like, if you
But he has a
change the name,
whole. Yeah, he has a whole YouTube.
well, you know that one saying that people say, you know, where'd you come from, where'd you go, whatever. That's supposed to be some kind of weird thing, you know, to have some derogatory connotations to it. But you know, I'm sure a lot of weird stuff that people do have it, you know, whether it's a racial thing or just like you don't like your parents or you don't like the rules or anything, you know what I mean? Pretty sure all the songs have something to do with that in them about whatever. Freedom, you know, just anything that's like out of the norm that you'd be like, well, this ain't right. Or this is what's happening versus what you want to be happening.
Well,
no, but I do find it like peculiar that, you know, that we can get away with all these like Globers can get away with all the claims. And then like if you say, how would you prove this thing? And then it just gets flipped onto you, all these crazy questions like, well, how would you go about proving the globe? Well, how would you? It's like, what? And then every time they look for a measurement, why are they looking for not an actual measurement? They're always looking for like some kind of messed up off amount, like you got to be off by something, and your off by something has to turn into a fake average, which turns into a calculated assumed amount that becomes an actual amount somehow. So the Globers are always looking for a mistake in their math, to be their answer. They're not looking for direct anything.
sorry, Demok. I'm on a whole different vibe. That's a real song title, by the way.